Okay, sig number 4 is just some applications of derivatives, kind of like basic ones, and later on we'll do the more advanced ones like max and mins and all that stuff that we did at the end of the first semester. So the first problem is, for each problem, find the slope of the function at the value. Just remember that the slope, the way we find the slope in calculus of a function, not of a line, but of a function, is we take the derivative, right? The slope is the derivative. It's the instantaneous slope at a point, right? So if I had this function, then the slope of the function at a point, if the function was f of x, and this is like a x value of a, then the slope here is f prime of a, right? These ones are going to have slightly different notations. You know, we have a function t and r instead of y and x. So basically, we're going to take the derivative of this with respect to r, why r, because that's the variable that's over here, right? So we're going to get dt dr equals, because we're taking the derivative with respect to r, this is just, treat it like an x. If you want to, you can just go through and change these into x's, and that will probably make your life easier, but we do need to know how to deal with x's and y's, or things besides x's and y's. So dt dr, this is an r, not a t, dt dr is negative 4r minus 1. We want to know what's the slope when r equals negative 1, so we're going to plug in negative 1, and that will give us 4 minus 8, so dt dr is negative 4. Right, and that's the slope at r equals negative 1. Next one is find the points where the tangent line to the function is horizontal. So we're thinking, if I have some function like this, horizontal lines are straight across, right? So that would be here and maybe there. What we know about horizontal tangent lines is that the slope is 0, which means the derivative at that point is going to be 0 as well, right? And same for down here, right? The slope is going to be 0. So what do we need to do? Well, one, we need to find the slope function and then figure out for what x values is the slope function 0. So let's find g prime of x. This is going to require maybe some quotient rule. U prime v minus v prime u. So it's going to be u prime is 0 times this. Should I put the negative there? Minus 2x times 8 all over x squared plus 2 squared. And I do need to be careful about this negative because it's kind of multiplying the entire thing, right? You can think about it like this. Alright, so this 0 term just goes away. This negative is going to distribute in there and give us g prime of x equals 2 times 8 is 16, so it's going to be positive 16 because this negative multiplies that negative over x squared plus 2 squared. Basically, we want to know when is the slope 0, right? When is the slope 0? So g prime of x is the slope. We want to know when it's 0. So we're going to take our derivative and we're going to set it equal to 0. We're going to say 0 equals 16x over x squared plus 2 squared. Okay, when you're looking at these, if you want to know when it's 0, you're looking for when does the numerator equal 0, right? The denominator has nothing to do with it being 0. The denominator will tell us if that's 0, it'll tell us when it's undefined, but we're not looking for that. We're looking for horizontal, right? So basically all we need to know is when does 16x equal 0? Well, that's when x equals 0, right? So when x equals 0, there will be a horizontal tangent line. Again, if you're just looking for horizontal tangent lines, you can ignore the denominator because all that will do is make it undefined. Another way to think about it is you could technically multiply both sides by x squared plus 2. It'll cancel out on this side, and you multiply this side by that, and those will cancel too. Or they won't cancel. Well, 0 times anything is still 0, right? So that little bottom piece becomes big and significant. Okay, next piece. For each equation, find A, the equation of the tangent line to the function at the given point. Your answer should be in slope-intercept form. and B, the equation of the normal line to the function at the given point. Your answer is being slope-intercept form. So tangent line, we're thinking this y minus y1 equals mx minus x1. And then normal line, all you need to know is that normal lines have opposite reciprocal slopes. So the normal line is going to have the slope negative 1 over m. Like just flip and get the opposite sign. So again, we're given x1, y1. We need m, right? We need this m, which is going to be the derivative. So h prime of r is going to be, again, we have a quotient rule here. This one's kind of unfriendly, but it's going to be 0. Derivative of 1 is 0 minus derivative of this is 1 over this squared. And clean that up, we're going to get negative 1 over r minus 1 squared. And we want to know the slope at 2. So we're going to go ahead and plug in 2 here. And we're going to get negative 1 over 2 minus 1 squared, which turns out to be, oops, I forgot the 1. 2 minus 1 squared, which turns out to be 2 minus 1 is 1, so this is negative 1. And so our tangent line is y minus 1, that came from here, and I'll put the 2 right here, and then we'll put the slope here, which is negative 1. Right, and then the normal line is the same. It's going to be exactly the same except for the slope, and the slopes is going to be the opposite reciprocal. So opposite meaning since it's negative here, it's going to be positive here, and then you have to flip it. So this was kind of a bad example because it didn't have like a slope that you can see. But let's pretend instead we had this. This is just like a pretend case, so I can give you a good example of how to do this. Let's pretend this was 1/2. Right, the tan line was 1/2. Then the normal line would be y minus 1 equals, we're going to flip this, so instead of 1/2 it would be 2 over 1, and because the tangent line was positive, the normal line is going to be negative, right, and so it would just be that, right, flip it, make it the opposite sign. Next one is find the indicated derivative with respect to given variable. So we're taking the derivative of this 2 times, right, that's what it means, taking the second derivative. So the first derivative, df dt, is going to be 20t to the 4th, and the second derivative is going to be 80t to the 3rd, right? Just power rule 2 times in a row. Pretty simple, just notation kind of stuff. For each problem, find the average rate of change of the function over the given interval. Also find the instantaneous rate of change at the leftmost value. So leftmost value is that one, right? That's the one that's on the left. So average rate of change, AROC, some people call it, is slope of a secant line. Which is f of b minus f of a over b minus a. Right, so start with that. This is a and that's b. So average rate of change is going to be g of negative 3/2 plus minus g of negative 2 over negative 3/2 minus 2. It's the average rate of change, right? And g of negative 3/2, so you plug in negative 3/2, you're going to get negative 9/4. You plug in negative, 9/4 plus 2, negative 9/4 plus 2, which 2 is 8/4. So that's going to be negative 1/4. Right, so g of negative 3/2 is negative 1/4. G of negative 2 is negative 4 plus 2, which is negative 2. All over negative 3/2 minus 2 is negative 7/2. So this is going to give us, this here turns into a plus. So negative 1/4 plus 2 is 1 3/4. also known as 7 fourths, divided by negative 7 halves. A little bit of, multiplication here. You're going to get 7 fourths times negative 2 sevenths. Those will cancel. You get negative 2 over 4, which is negative 1 half. Okay, that's the average rate of change. Instantaneous rate of change is simply the derivative. So we're going to take the derivative, g prime of s equals negative 2s, and then it wants at the leftmost, so that's at negative 2, so g prime of negative 2 is going to be negative 2 times negative 2, which is 4. And that's our instantaneous rate of change. All right, this is not mean value theorem. You don't have to find when they're equal. It's just simply trying to get you to see the difference between average rate of change and instantaneous rate of change and how they are obtained. All right, so I hope this is helpful. Good luck.